fact not the same thing. So let's get some definitions down right away. Precision versus accuracy, how are they different? Well, first of all, when I think about precision, this is my definition. All right, it's the degree of exactness with which an object or a substance could be is measured, and that substance could be a powder, it could be a liquid. It doesn't really matter. And the thing that I like to think about is that generally, the more numbers there are past a decimal point, the greater the degree of precision is. Now, accuracy, in short, is really whether or not a measurement has been made correctly. So, if you think about this definition, that is how close a measurement is to the accepted or actual value that something is, that's accuracy. So, let me illustrate this for you so I can help you understand a little bit more. So when you look at these two pictures, what we have here on the left, this is liquid, which has some blue coloring in it probably, in a beaker. And this is some clear liquid that's in a graduated cylinder, and this is a close-up photo. Now, these numbers down here, what I want you to focus on, this 200 ml, that means milliliters, that has to do with this particular amount of liquid in this beaker. And this 7.21 milliliters has to do with this amount of liquid in this graduated cylinder. So when you look at these two values, which do you think is more precise? Well, what you should have answered here is this one. This 7.21 is more precise. And the easy way to tell that is that there's more numbers past the decimal point. This is a very precise measurement, whereas this is not a very precise measurement. And another thing to really realize here is that a beaker is not a very precise piece of equipment to use to measure a volume, whereas a graduated cylinder is a more precise piece of equipment to measure a volume. And one of the easy ways to tell whether or not a device is more or less precise is really the physical distance between the markings or the graduations in these on these pieces of equipment. So, the actual physical distance here between this line and this line, if you're following where the mouse is here, and the physical distance between this line, and this picture is blown up, so it's kind of hard to tell. But this is a much more close marking if you were to look at an actual to scale, not just blown up picture of a graduated cylinder. Now, in contrast here, let's think about which reading is more accurate. All right, so how are we going to read this? Well, we can look at where this liquid is in this beaker and look at where the line is, and this marking right here is indicating that it's 200 ml, and notice this says plus or minus 5. So that has something to do with how accurate or precise this particular piece of equipment is. And the reading down here that's recorded is 200 ml. To me, that's accurate. Now, if you look at the graduated cylinder, the 7.21, as it turns out, even though it's more precise, is not accurate. This line down here marks 6 or 6.0 milliliters on this graduated cylinder. This line up here marks 8 or 8.0 milliliters on this graduated cylinder. This line, which is not as long as those other lines, but halfway in between those two, would be 7. And when you read how much liquid is in a container, very often what you'll see is that there's a curvature. There's like what we call a meniscus when we look at liquid in a cylinder like this, a glass container. And what we do is that we read from the bottom of that meniscus. Now, clearly, this bottom of this meniscus is below this point, which is 7. So I know this isn't accurate. So what we're going to do here is read this more carefully so that we can be both precise and accurate in our measurements. Now, let's think about this term uncertain. Obviously, the definition there is that which you don't know for certain. If you're uncertain about something, you don't know something for sure. In any quantitative measurement in chemistry, what I want you to try to do is record a measurement that's precise enough so that you're estimating that last number that you're writing down. So what that means is that last number is uncertain. You might think of it as a doubtful digit. Now, when I look at this picture here again, and I've just made it a little bit smaller for this slide, 6.62 milliliters would be both an accurate and a precise measurement to the right here on this picture. So let's look at this. If this line right here is 6, and that line right there is 7, and all of these marks show a gradual difference between those measurements, you got to do some math here. There are 4 marks in between this 7 line and this 6 line. So what that means is that this line marks 6.2, this line marks 6.4, this line marks 6.6, and this line marks 6.8 in between this 7 and again down here this 6. So when I read from the bottom of the meniscus, that bottom of the curved liquid, I'm going to call that 6.62. Now, you might measure that as 6.61 or 6.63 because it is just, this bottom of this meniscus is just above this 6.6. But what I want you to do is estimate, be 1 decimal place smarter than the device you're using, so to speak. So I want you to list 1 more place value than you know to be certain when you're making your measurements. All right, so hopefully that helps you understand the difference between what accurate is and what precision is. They are not the same thing, but I want you to be both accurate and precise when you're making measurements in chemistry this year. Thanks, ladies and gentlemen. Hope you learned something. Bye-bye.